Quality assurance in production industry. Learning points. 1. Quality assurance. What does it mean? 2. The influence of man, methods, materials, machine, measurement, and environment on the production process. Quality assurance. What does it mean? Let's define some basic concepts. Quality management system, quality assurance, quality control. Quality management system, QMS, resides at the highest organizational level to establish the overall quality policy. In other words, a QMS gives direction, that is, what needs to be achieved. Quality assurance, QA, provides the management tools for the achievement of the quality policy or high-level strategy spelled out in the QMS. In other words, QA is the how to achieve the objectives of the QMS. Quality control, QC, is basically the results of the QMS in terms of the product parameters. Let us use another scenario to explain these concepts. Quality, process, and product parameters. For any product, quality is subject to consumers' perception of taste, feel, color, smell, and how audible for products that make sound. In other words, the quality of a product is what the consumers say it is. Quality parameters are basically the quality objectives of the organization. They embody the characteristics of the product and the processes that lead to the realization of those characteristics. QMS gives direction by setting the quality parameters. With respect to production, process parameters are the influencers of the production process. That is, the characteristics of machines, materials, methods, manpower, measurement, and even the environment. All of these have direct or indirect impact on the final product quality. QA monitors the characteristics of these variables to ensure the product parameters are achieved. Product parameters are the characteristics that describe a finished product. These are the attributes consumers see or feel before making the buying decision. Though consumers cannot measure product parameters, however, they use their senses of sight, taste, smell, and touch to pass their judgment on the product quality. QC confirms the final product parameters before they are released to trade. The influence of machine, materials, methods, measurement, man, and environment on the production process. The fishbone Ishikawa diagram establishes that a production process uses machinery, methods, and human resources to transform measured raw materials into a finished product, and not forgetting the impact of the operational environment. This part 1 will focus on machines. A machine is any piece of plant, machinery, instrument, or tool which is used for carrying out a specific activity or operation, e.g., mixers, millers, fillers, pumps, etc. Production process depends upon the good performance of these machines. How do you achieve product quality with machines? 1. Machine maintenance. 2. Machine quality points. 1. Machine maintenance. Effective machine maintenance has a great role in achieving the desired product quality. A machine that is not in basic condition can be likened to a sick employee. Such machine cannot deliver the expected outcome. There are two major categories of machine maintenance. 1. Planned maintenance. 2. Autonomous maintenance. 1. Planned maintenance. Planned maintenance is the third pillar of the TPM methodology. It is a maintenance approach to achieve zero breakdown. It is carried out by the maintenance team. There are 4 basic planned maintenance philosophies. 1. Corrective maintenance. 2. Preventive maintenance. 3. Risk-based maintenance. 4. Condition-based maintenance. 1. Corrective maintenance, CM, also known as breakdown maintenance. The machine runs and breaks down before it is looked into. It is a reactive approach and less expensive. How does this impart realization of quality products? Components of the machine must have been failing before final breakdown. For instance, a pack weigher before breaking down must have been aligned product packs of lesser weight passed through to final packing due to some faulty components that were not attended to before the eventual breakdown. 2. Preventive maintenance, PM. This type is carried out at planned intervals aimed at reducing the degradation of the equipment. Machine components need not go bad before replacement. Most manufacturers avoid preventive maintenance due to cost. How does this impart realization of quality product? The equipment manufacturer could recommend that the pack weigher in our earlier example be inspected and serviced every 6 months or after a certain number of hours of operation. If this recommendation is judiciously followed, one can be sure of the right weight at all times. 3. Risk-based maintenance, RBM. RBM places emphasis on machines that carry the most risks to safety, quality, or productivity if they were to break down. In this approach, machines are categorized according to their criticality in what is called criticality assessment. How does this impart on realization of quality products? It depends on the organization's priority. If production output is higher on the priority scale, it means the machine will not receive attention for quality issues, so long as it keeps running and producing. 4. Condition-based maintenance, CBM. CBM is a strategy that monitors the actual condition of a machine to decide what maintenance needs to be done. CBM dictates that maintenance should only be performed when certain indicators show signs of decreasing performance or upcoming failure. Condition-based maintenance can also be termed predictive maintenance. How does this impact realization of quality products? It can lead to a sudden breakdown of the machine condition was wrongly predicted. In reality, it is difficult for manufacturers to stick to one of these strategies to achieve their maintenance objectives. One approach cannot fit for all machines in all situations. This introduces a more robust maintenance approach called Reliability-Centered Maintenance, RCM. RCM tends to combine the preventive, risk-based, and predictive strategies in view of scarce resources towards achieving a balance in quality and productivity objectives of the organization. It is important that quality assurance professionals understand these approaches and follow through on maintenance of critical quality equipment instead of leaving all in the hands of the maintenance team.